So welcome back, ladies and gentlemen. We're going to try to do some other questions. As you can see maybe from this chalkboard over here, that's the answer, the one in green, to the question 1B, example B from the package. I decided to make one up really, and I'll zoom in so you guys can all see it. In brown here, we have y equals sine bracket 2x plus 90 degrees minus 1. And so hopefully, and I just made this one up, ladies and gentlemen. I like doing this analysis first of all. So any volunteer from the class would like to help us out? The A, P, EOA, or S? Any volunteer? For somebody new? Did anyone try?
So the A is 1.
Nice! First of all, notice the A is 1, the absolute is 1.
S is negative 1.
S is not negative 1.
Oh.
The equation of the axis is negative 1.
Oh, it means that's right.
It's okay.
And then S is negative 90.
It's not negative 9. This was a trick question. Can someone help her out? You're my guinea pig that I wanted to show it. So notice it says plus 90 here, but I'm trying to trick you. Emma?
45.
Yeah, so this question actually should be this. Y equals sine 2x plus 45 degrees minus 1. You always have to factor out that k. So that's why you can't forget that. So in this case, I think Emma said left 45 degrees. Or negative 45, but that's correct. So our last one here is the period. Any volunteer? Or Padina, do you know what the period is? Now that the period is 2? Or the k is 2? It's not 2. You get to do a calculation. Ryan, want to help her out? Sorry? 180. And again, notice, although k is related to period, it is the only one that you have to do a calculation for. So, for the k. So in this case, 360 over 2. Hopefully people at home are watching that. And again, if you want to pause the video, feel free to do either the stepwise, the transformations, or do the fast way. But if you pause the video, I'm going to show you again how to do the fast way for this question. And again, here it is. Here's the fast way. I draw a skeleton of our graph or a function. This is not cosine, it's sine. So I'm going to just draw a skeleton that looks like this, without any markings on the x and y axes. And then I fulfill the criteria. Again, if you don't get the analysis right, then you're going to obviously draw something incorrect. So there is a weakness with this method, right? But it ensures that we're doing things right. And I like actually dealing with the equation of the axis first. The equation of the axis is negative 1. So right along this line, I'm going to make that negative 1. And then even though I deal with the amplitude next, I know that my maximum and my minimum, in this case my maximum is going to be 0, and my minimum is going to be negative 2. Because I'm dealing with the amplitude and then equating the axis simultaneously. Then we just have to finish this off. This is our phase shift, which is not negative 45 degrees. And again, if you got that wrong, that 90, there's going to be a problem. So I write down here, that's negative 45 degrees. And then I have to ensure that it has to equal to 180 degrees. And that means this distance must be 180 degrees. So this endpoint is going to be 135. The other piece of information is going to be pretty easy to do. I think that is 45, is that right? I'm so stupid. That's 45 degrees. And then that maximum at 0, and the minimum at 0. How do I always do this myself? What is that? Someone help me out. 90. That's 90? That can't be 90. This is 90, right? Yeah. Something seems off. So this is 0. That's 0. Okay, so that's where we got those critical points. So this something looks a little bit better. And then what we do is you take those critical points, those 5 critical points. Negative 45 and negative 1, 0 and 0, that's actually the origin. Negative 1 and 45 degrees, 90 and negative 2, and then 135 and negative 1. Plot those points at home, ladies and gentlemen, and you have your function. I'll get out of the way in case you need to see it.